This is Dr. D. Khalandar Basha, working as Associate Professor in the Department of Electronics and Communication Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to discuss the 8051 serial communication related problems. So for transmission of the data as well as receiving of the data, we will see with few programs. So 8051 microcontroller is consist of a UART where we can transmit and receive the data. The data can be either 8 bits or 9 bits data we can transmit with a fixed baud rate or variable baud rate. The slides are prepared by referring the textbook, the 8051 microcontroller, Kenneth J. Ayala, publication, Singer's Learning. In 8051 microcontroller, for serial communication, that is to allow the data transfer between the PC and 8051 microcontroller without any error, ensure that the baud rate of 8051 system matches the baud rate of personal computer COM port. Notice that dividing of the oscillator frequency by 12, then followed by dividing the clock frequency of the mission cycle with a 32 will give us the default value upon activation of the 8051 microcontroller. So crystal oscillator, it is going to generate a frequency of 11.0592 MHz. For one mission cycle, we are going to divide the oscillator frequency by 12. So we are going to get a frequency of 921.6 kHz. For providing the baud rate for UART, we will divide this frequency with 32. Then the baud rate for generation is taken as 28,800 Hz. So depending upon at what rate the data has to be transmitted or received, this will be divided with some value that will be loaded into the timers. Now we will see for providing the standard baud rates. So how we can fix the value of the count in timer 1 register, we will see with XTAL, that is oscillator frequency of 11.0592 MHz. Find the value of TH1 needed to be loaded to have the following baud rates: A 9600, B 4800, C 2400, D 1200. The mission cycle frequency of 8051 will be generated by dividing the oscillator frequency by 12, that is 11.0592 divided by 12, that will give us the mission cycle frequency 921.6 kHz. And for frequency of UART for timer 1, to set the baud rate, we will divide the frequency of the mission cycle with 32. So that is 921.6 kHz divided by 32, which will give us 28,800 Hz. In the problem A, we want to generate the standard baud rate as 9600. So for generation of 9600, so the baud rate of UART is 28,800 divided by 9600. That will give us 3. So we have to decrement the count by 3 times. So the value which we are going to load into the TH1 register should overflow after 3 clock pulses. So for this 3 clock pulses, the count value we can generate as the TH1, the maximum value is 255. As it is a 8-bit timer, the maximum counts we are going to have is 256 minus 3, that is 253, which is in decimal. Now we will convert this one into hexadecimal, that is equivalent to FDH. So this FDH we are going to be load into the TH1 register of timer 1, where we are using this timer 1 for auto reload mode. So if FDH is loaded into TH1, for the next clock pulse, this will be incremented by 1. So we are going to get as FEH. For the next clock pulse, this count will be incremented by 1, so which is going to generate FFH. For the next clock pulse, we will be increment this one where the value of TH1 is getting overflow from maximum value to minimum value. There we are going to expect overflow. That is TF1 will be generated. Now if you observe how many clock pulses we are requiring here, 3 clock pulses. So for that we are going to load the TH1 as the maximum value. The total number of counts is 256 minus 3. So the 253 will be generated, that is in decimal, that if you convert into hexadecimal, FDH. The another way is we can subtract maximum value, that is FF minus 3. FF minus 3 is F is 15. 15 minus 3, 12. That will get as C. F. As the count is starting with 0, we are going to add plus 1, so which is generating FDH. So this is the equivalent of minus 3. So any one of these we can remember. So the value which we want to load into TH1 register for 9600 baud rate is FDH. Now we will move to the second case, where in the second case the baud rate which we require is 4800. For generation of 4800, the baud rate which is required is 4800. The mission cycle of 8051 microcontroller frequency is equivalent to the oscillator frequency, that is 11.0592 divided by 12, which is going to give 921.6 kilohertz. From this frequency, we are going to generate the frequency of the baud rate to be given for the timer 1 in auto reload mode is given by the mission cycle frequency, that is 921.6 kilohertz will be divided by 32, which will generate 28.800 hertz. So from this hertz, we are requesting for a baud rate of 4800. When you divide 28,800 with 4800, which is going to give 6. So now this 6 is the number of clock pulses which we require for generation of the overflow for TH1. So what is the count I have to load here? For that, there are many mechanisms. The first case is the total number of counts for 8-bit is 256 minus 6. These many number of clock pulses are required. So the value which we want to load into the TH1 register is 250 decimal. In the hexadecimal, you can write as FAH. The second way is the maximum overflow will get, that is maximum value we can have in TH1 is FF. From that, subtract 6. F minus 6, F is 15. 15 minus 6, which will give us 9. This is F. As the count is starts with 0, we are going to add plus 1. So F9 plus 1, 9 plus 1, 10 in decimal. In the hexadecimal it is A. Here it is F. This is FA value. Otherwise, it is equivalent to how many clock pulses we are subtracting? 6. So minus 6 also we can take. The TH1 we had to load with FAH for supporting a baud rate of 4800. The third case is we want to generate a baud rate of 2400. The mission cycle frequency of 8051 microcontroller is given as the oscillator frequency, that is 11.0592 megahertz divided by 12, which is going to give 921.6 kilohertz. From this frequency of the mission cycle, we are going to be find the frequency of UART of 8051 microcontroller by dividing 921.6 kilohertz, that is mission cycle frequency, divided by 32, which will give us 28,800 hertz. From this 28,800 H, the baud rate which we require is 2,400. Now when you divide the 28,800 divided by 2,400, we are going to get the value is 12, which means the 12 clock pulses are required for providing a baud rate of 2,400 by using timer 1 in auto reload mode. So how the count we have to load into the registers of TH1. So in the first step, our one method is the 8-bit size counter will have the total number of count is 256 minus the required count is, that is required number of clock pulses are 12 only. So 256 minus 12, which is 244 decimal. That if we convert into hexadecimal, we'll get F4H. Another way is, this is method 1 I'll take. In method 2, you can take as the maximum count we can have is FF minus 12, the required number of clock pulses, F minus 2. F is 15, 15 minus 2, 13. So 13 equivalent is 12 clock pulses. 12 means C. 12 is in decimal. In the hexadecimal, it is equivalent to C. F minus C. F is 15 minus C. C is 12. That is 15 minus 12, which will give us 3. Here it is F. As the count will be start with 0, we have to consider it. So add +1 for it. So now the count we have to load is F4. It is also equivalent to minus 12H. So for supporting 2400 baud rate, the value which we have to load into TH1 register is F4H. The next case is, we want to find the count to be loaded into the TH1 register for baud rate is 1200. We know the oscillator frequency is 11.0592 MHz. From that, we will find the mission cycle frequency of 8051 microcontroller is the oscillator frequency, that is 11.0592 MHz divided by 12, which will give us 921.6 kHz. This is the mission cycle frequency. From this mission cycle frequency, we will calculate the frequency of the baud rate of 8051 microcontroller by dividing with 32. That is 921.6 kHz divided by 32 will give us 28,800 Hz. This is the frequency by UART for the timer 1 to be set for baud rate. So in this 28,800 Hz, we require the baud rate is 1200. So now if you divide 28,800 divided by 1200, we will get this value as 24. What is the value we have to load in TH1 register is the maximum number of counts for 8-bit case is 256 minus 24, which is going to give as 232 decimal. 232 decimal value we have to load into the register TH1. In the hexadecimal, the equivalent is E8H. This is method 1. In the method 2, the maximum count for 8-bit timer is FF. From this, we have to subtract 24. This 24 is a decimal. Its hexadecimal equivalent is 16 plus 8. So 24 decimal is equivalent to 18H. So subtract 18H from the maximum count, that is FF. F minus 8. F equivalent is 15. 15 minus 8, which will give us 7. F minus 1. F equivalent in decimal is 15. 15 minus 1, 14. In hexadecimal equivalent is E7. The count is starting with 0. For inclusion of that, we have to add +1. So the count which we have to load into TH1 register is E8H. Otherwise, it is equivalent to minus 24. How many clock pulses we have to take? That many we have to go into subtract. That is minus 24 equivalent is E8H. So for providing a baud rate of 1200, we had to load E8H into the TH1 register, where the timer 1 is configured in auto reload mode. So the values which we had to load for 9600 is FD, 4800 is FA, 2400 is F4, 1200 is E8. And the mode of configuration is auto reload mode. Next, we will see a program for transmission of the data through 8051 serial communication. So write a program for the 8051 microcontroller to transfer letter A serially at baud rate continuously. So the baud rate is 4800 is FA, we have to load into TH1 register. So for solving this problem, the various steps we have to follow is, first we have to configure the time by configuring T mode register, which will specify which timer we have to use. Either we have to use as timer or counter, and what is the mode of operation we can configure in the T mode register. Later, load the count in TH1 register. After configuring the T mode into auto reload mode, then we are using timer 1, that auto reload count we are going to be loaded into TH1. Then start timer. So for starting the timer, we have to set the TR bit is equivalent to 1. So as we are using timer 1, TR1 is equivalent to 1. Once the timer is started, whatever the data which we want to transmit, that should be loaded into SBUF. Once the data is loaded into SBUF, this data will be transmitted bit by bit, because it is serial communication on TXT line. Once all the data is transmitted, then we can ensure the completion of the transmission using TI bit. Transmit interrupt. So if TI is equivalent to 1, indicates the transmission is done. If TI is equivalent to 0, so still transmission is in progress. So when transmission is in progress, again read TI bit until the transmit interrupt is equivalent to 1. Once the transmit interrupt is 1, then clear transmit interrupt. Further action, whether if you want to go for continuous execution, go for a jump instruction, otherwise we can terminate the program. So as per problem statement, we want to transmit letter A serially at a baud rate of 4800 continuously. So first we will configure the T mode register. The T mode register is having 8-bit size, where 4 bits are configured for timer 0 and 4 bits are configured to timer 1. As we are using only timer 1 and timer 0 we are not using, these things are don't cares. So we can configure anything 000 to 1111. So default value usually take us all bits as zeros. Next, for timer 1, the mode is auto reload mode, that is mode 2. For configuring the timer 1 in auto reload mode, write M1 M0 as 10. The next one is, we want to use this one as a timer. So C by T bar pin should be equivalent to 0. So C by T bar is equivalent to 0. As we are not expecting any external interrupts, so the gate signal is equivalent to 0. So the equivalent value is 0, 0, 1, 0 followed by 0, 0, 0, 0. So the T mode register we had to load with the value of 0, 0, 1, 0, 0, 0, 0, 0. Equivalent is in hexadecimal 0. This is 0, 0, 1, 0 is 2, 0. So this 2, 0 we have to load into T mode register by using move instruction. Once the T mode register is configured, then we have to write the count for providing the baud rate as per problem statement into the TH1 register. So for generation of 4800, the baud rate So we have to load FAH into TH1 register by using the instruction move TH1 comma hash 0 FA. As the count is starting with an alphabet, it has to be proceed with 0. So we are loaded T mode, we are loaded TH1, then we have to configure the SCON register. So here after this one more step, SCON register. So for configuring SCON register, the SCON is 8-bit size. The mode of operation we are taking, it is 8-bit variable baud rate. As it is single process, SM2 bit is equivalent to 0. For enabling the receiver, REN is equivalent to 1. As it is only 8-bit transmission, so TB8 and RB8, these are actually don't gets. So we will write these bits as zeros. And TI and RI, these are generated by the internal hardware of the timers. So the values which we are going to be write as default is 0. Next, the value which we are going to generate for SCON register is 01010000. That is 00101. That is 5. So 50H we have to load into SCON register. To start the timer, we have to write TR bit is equivalent to 1 for starting the timer 1. So how we can set the TR bit is equivalent to 1 is by using set B instruction. Which bit we want to set is TR1. The next step is we have to start the timer. Timer is started. Then what are the data which you want to transmit, that we have to load into SBUF. Move SBUF comma hash A. As it is a character, we are going to be code that one. So whatever the data which is there in the SBUF, this will be transmitted on TXT line bit by bit. We can know the data is transmitted by checking the TI. For checking this TI, we will write JNB TI comma L2, which means when the TI bit is equal to 0, still the transmission is taking place. So we are going for checking the TI bit, that is polling method. So till the TI is equal to 1, this will be executed repeatedly. Once TI is equivalent to 1, will come out of the loop, where we can clear the transmit interrupt by using the instruction CLR TI. So once the transmission is done, only one time we are transmitted A. If I want to transmit that A for multiple number of times, go for jump instruction. We will go for loading the SBUF into corresponding value. SBUF with the corresponding value. So once the data is transmitted, once all the data is transmitted, SBUF will become empty. So again we have to reload. So that's why we are reading this one to loading into SBUF. So this is the program for transmission of the letter A continuously by using 8051 microcontroller serial communication. Now we will see the programs at a glance. First instruction is move T mode comma hash 20. This is for using timer 1 in auto reload mode. Then for providing the baud rate as per the problem statement, in this case it is 4800. So we load FA into TH1. Then configure the serial port using SCON register. We are going to load the SCON with 50H. Then start the timer by setting TR bit is equivalent to 1. So for that set B TR1. Next, what are the data which you want to transmit, that we are going to be loaded into SBUF by using the instruction move SBUF comma hash A. Next, once the data is transmitted, we will signify that one using the transmit interrupt. So we go for checking JNB TI. So if TI bit is not set, go for checking, that is polling method. Until TI is equal to 1, this will be executed in the same instruction. Once the TI bit is equal to 1, it will come out of the loop. Then we are going to clear the TI by using CLR TI. Once the clear is done, so one time we are transmitted. If I want to go for continuous transmission, S jump L1. Here L1 is going to be loaded again with the accumulator content. So this is the program for transmission of the data A serially and continuously with a baud rate of 4800. Now write a program for the 8051 microcontroller to transfer IARE serially at an baud rate of 9600. As UART supports in 8051 microcontroller, it will have 8 data bits and 1 stop bit. So no need to specify the stop bit exclusively. Automatically the stop bit will be appended by the hardware itself. Here also the steps. The first step is configuring a T mode, loading TH1 for the supporting baud rate. Next SCON. Next start timer. Then data to be transmitted into SBUF. Then check for TI. If TI is equivalent to 1, clear TI. You can terminate the program or you can go for repetition. Either termination or repetition. So for configuring the timer 1, we are using only timer 1. Timer 0 bits are don't get. So you can write any bit. I am taking the default values as 000. The mode of operation is auto reload mode, that is mode 2. So for that we will write 10 in M1, M0. Next we are using this one as a timer. So C by T bar is equivalent to 0. As we are not using the ANT pin for the initiation of the timer, so we are going to write gate pin is equivalent to 0. The equivalent value for T mode register is, so the T mode register we have to write the value as 001000. So that is 0, here it is 2. So 20H load into T mode register by using move T mode comma hash 20H. Then for supporting 9600 baud rate, the value which we have to load into the TH register is FTH. For 4800 FA, for 9600 it is FTH. Next, configuring the SCON register. So SCON is 8-bit size. The mode of operation is 8-bit variable baud rate. So we will write SM0, SM1 as 01. As it is not a multiprocess system, we will write SM2 is equivalent to 0. For enabling the receiver, REN is equivalent to 1. So it is 8-bit communication. So you will write TB8 and RB8 is equivalent to 0. So this TI and RI bit are status bits. So you will write default values as 0. So the equivalent value which we are going to be load into SCON register is 01010000. So the equivalent is 50H. So 50H we are going to be load into SCON register. Then to start the timer 1, we use setB TR1. So now the timer will start executing. Next, what are the data which you are going to be transmit, that we will load into accumulator. So move A comma I. Here our intention is for transmission of IARE. So first I will be transmitted, followed by A, R and E. So then we will call a subroutine. A call, the subroutine name is transmit CH, transmit character. TXCH is the subroutine name we are considered. Then once executing the subroutine, again we will come back to the next instruction where the second character we are going to be transmit. That is move A comma hash A. Then call again in the subroutine. So what is the subroutine should consist? So once the data is loaded into A, so this A data we have to load into SBUF, because always SBUF data will be only transmitted. Once the data is loaded, check for TI. If TI is equivalent to 0, go for executing, that is polling method. If TI is equivalent to 1, clear the TI. So for that, we will, after passing I, A, next one is we will pass for R, E in the same manner. Then for execution repeatedly, we will write sjump L1. Now what we have to write in this subroutine TX comma CH. So in the TX comma CH subroutine, we will write first accumulator contents will be loaded into SBUF by using the instruction move SBUF comma A. Then this SBUF data will be transmitted serially until TI bit is equal to 1. So if TI bit is equal to 0, go for polling method by using JNB TI, where it has to redirect to the same instruction. So we'll give a label for L2. So once TI bit is equal to 1, we'll come out of the loop. So where we are going to clear the transmit interrupt, then we are going to be written from this subroutine to the main program. So the last instruction we had to write for a subroutine is RIP instruction. So this is a subroutine program. Now we will see the entire program at a glance. Move tmode comma hash 20h. This is for configuring the timer 1 into mode 2, that is auto reload mode. Move th1 comma ft. This is for setting the baud rate as 9600. Next, move scon comma hash 50. This is for configuring the serial mode for mode 1 with a variable baud rate and 8-bit data. So we are going to be write scon as 50h. To start the timer, set b tr1. So the timer 1 will start executing. Then we will move the I value into accumulator. Then we'll call a subroutine. After executing the subroutine, move second character, that is IA, will be loaded into accumulator. Then call subroutine. Next data we want to transmit is R. Next one is E. So once all the characters of IARE are transmitted, if you want go for repetition, so sjump L1. Otherwise, you can terminate the program. So in the subroutine tx comma ch, we are going to write move sbuff comma a jnb ti comma L2 clear ti, then RIT instruction. This is for return from subroutine. So now the program execution will terminate from subroutine to main program. The same thing we can write without calling a subroutine. So how we can write is, first you will write move tmode comma hash, tmode is loaded with 20h. For supporting the baud rate, move th1 comma hash, the value which we have to load is fdh. Next, scon, move scon comma hash 50 for configuring the timer. Then start timer, that is set b tr1. So once the timer is started, so what are the data which you want to load, that we are going to be moving to sbuff. Move sbuff comma, the first character which you want to transmit is I. Then this data we will check either the transmission is done or not by using JNB TI comma L2, where L2 will be placed to the side. Next, once this I is transmitted, we are going to clear that particular transmit interrupt, that is clear TI. Then we go for moving the second data, that is move sbuff comma, the second character which we want to transmit is A. Then we check for whether the transmit interrupt is active or not, so that we are going to be checked. If transmit interrupt is active, then the clear that particular transmit interrupt. So I is transmitted, A is transmitted, then we want to transmit R. So for that, move sbuff comma hash R. Then check for TI JNB TI comma loop 4. Once TI bit is equal to 1, so clear the transmit interrupt. So R is also transmitted. Then we want to transmit E. So for that, move sbuff comma hash E. Then check for transmit interrupt JNB TI comma L5, where L5 will be given to the same instruction. Next, once the TI bit is equal to 1, clear the transmit interrupt. So you have transmitted I, A, R, E. Then if I want to go for executing repeated, simply will write sjump L1, where L1 we have to load is loading the first data again. So this will be executed repeatedly. So this is the program for transmitting of IARE continuously through serial port at a standard baud rate of 9600. Now I will move to the next program. Program the 8051 microcontroller to receive bytes of data serially. Put them in port 1. Set the baud rate at 4800 for asynchronous communication with 8-bit data and 1 stop bit. So for configuring the 8051 microcontroller for serial communication at a particular baud rate, the various steps we have to follow is: first, configure a mode register, then load the count into TH1 register, then configure SCON register. After that, start timer 1. Once the timer 1 is started, then we can go for, this is receiving, so check for RI bit, that is receive interrupt bit. Previously for transmission we have checked TI, now we are going to check RI. So if RI is equivalent to 0, that indicates the data is not received. So go to check RI again. When we have to terminate is, if RI is equivalent to 1, the transmission is done, then clear. Before clearing the RI, load the received data which is there in SBUF to the accumulator. As per problem statement, this data contents we have to load to port 1, then clear receive interrupt. Then go for termination or repetition of the instruction. Now we will see step by step. Move tmode comma #20. This is for configuring the timer 1 into auto reload mode. Only timer 1 we are using. So 20 we are going to be loaded into tmode register. For supporting 4800, the TH1 we have to load with FAH. For 8-bit data transfer, so we'll configure SCON with #80. Then we'll start the timer by using setB TR1. So timer 1 is started executing here. First we check for whether receive interrupt is active or not by using JNB instruction. So what this instruction will do, it will check whether RI is equivalent to 0 or RI is equivalent to 1. If RI is equivalent to 0, that indicates still the receiving of the data is taking place. So we go for waiting, that is again go for polling the receive interrupt RI. So once RI is equivalent to 1, then SBUF data we can read. So for collecting the SBUF data into accumulator, move A comma SBUF. As per problem statement, whatever the received data is there, that we want to send to the port 1. So move P1 comma A and clear the RI. If you want to execute or receive the data repeatedly, yes, jump L1. So this clear RI, either we can write here, or once you have collected the data SBUF to accumulator, either you can write here or you can move here. Anyway, both are valid. So these two are interchangeable. So this is the program for receiving of the data serially using 8051 serial communication. Thank you. So in this session, we have discussed programs related to 8051 microcontroller. The first problem statement, we have discussed how to configure the TH1 value for various baud rates like 9600, 4800, 2400 and 1200. Later, we have seen two programs for transmitting a single character, later followed by transmitting multiple different characters. The last program is about receiving of the data using serial communication of 8051 microcontroller. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.